Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. Here you will find so many entrance exam question papers along with the detailed PDF solutions. For a better preparation of your exams, to download our app. The link is available in the description box. Students, in this particular video, I'll be solving CBSE Class 12 Chemistry Set 1 Delhi paper. I'll be solving all the chemistry questions in this video. So a very best of luck here. Start with the question number 1. It says, which of the following molecules has a chiral center correctly labeled with an asterisk? Okay. Let's look at all of these. If I'm looking, then the central one, that is the B1. This is having the arrangement as CH3, C, Cl. Here will be CH. 2Br and here is your H. Now, an atom with all the 4 different groups bonded to each in such a way that it has a non-superimposable mirror image. They are having the chiral center. No superimposable mirror image. Such arrangement is bound to is said to have the chiral center, and in this case you have option B as the correct answer. Hope you understood this. Let's move to the next question. Question number 2. It says, which of the following alcohols do not undergo oxidation? Butanol, butan-2-ol, 2-methyl-butan-2-ol, or 3-methyl-butan-2-butanol. The right answer to the question is option C, 2-methyl-2-butanol. Because tertiary alcohols, they do not undergo oxidation, and this is a tertiary alcohol. Let's see over here. This is CH3, 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 OH. This is a tertiary alcohol, and when they undergo, like in the presence of copper at 573 Kelvin, they will form alkenes. They undergo dehydration and form alkenes. Or like this. So, alcohols under tertiary alcohols undergo dehydration and they form alkenes. So you have C as the right answer. Hope you understood that. Let's move to the next question. Question number 3, a voltaic cell is made by connecting 2 half cells represented by these half equations. So looking at these equations, which of these following is true? Fe2 plus is oxidized and the voltage is minus 0.91 volt. Tin is oxidized and the voltage is given by this. Ferrous is oxidized and the voltage is this, or tin is oxidized and the voltage is this much. If I'm looking at all these options before discussing, we are having these 2 equations, these 2 half equations rather. So over here, you can see the reduction potential of ferrous ion, ferric ion. This is Fe plus 3. The reduction potential of this equation is greater. This is in the aqueous form, is greater than Sn plus 2. Therefore, this will be reduced and this one will be oxidized. Now, what will happen at anode? Let's see. Here you have tin. Tin will give you, lose 2 electrons to give you Sn plus 2. Here, the voltage will be given by minus 0.14 volt. And you have ferric over here, Fe3 plus. This will be adding, like I'll be adding 2 electrons to it. These 2 electrons which are lost, so this will be added at this place. So you have Fe plus 2. Let's do the balancing. Here will be 2, here will be 3. No, sorry, here will be, I've written the opposite. Here will be 3 and here will be 2. Okay, and yes, next. This is again aqueous. So you have E naught over here. This is plus 0.77 volt. So these are the two half reactions now. Now the overall reaction will be given by overall cell reaction, you can say, is given by 10 solid form plus 2 Fe plus 3. It will give you this in the aqueous solution, in the aqueous form, and 2 Fe2 aqueous. Here the E will be equal to 0.77 minus of 0.14, or E will be equal to 0.91 volt. So now let's look at the options. You have here tin will be oxidized and the voltage will be 0.91 volt. You have option B as the right answer. Hope you understood that. Let's move to the next question now. Question number 4. Four half reactions 1 to 4 are shown below. These are the four reactions. Now looking at them, let's read the question. Which two of these reactions are most likely to occur when concentrated by brine is electrolyzed? Okay, if I look at all the given four half reactions, the two half reactions that are most likely to occur when concentrated brine, that is, where it is, yeah, that is sodium chloride solution is electrolyzed, is the first one is this one. 2Cl minus gives you chlorine gas plus the two electrons. This will happen at anode. This reaction occurs at a node when chloride ion loses two electrons to form the chlorine gas, and the two electrons will be liberated. And what will happen at the cathode? This reaction, sodium will gain those electrons to form sodium metal. This reactions occur at cathode where the sodium gains electrons to form sodium as such. So you have first and third. That makes A option as the right answer. Hope you got that. Next is question number 5. Which property of the transition metals enables them to behave as catalysts? High melting point, high ionization enthalpy, alloy formation, or variable oxidation states? The right answer, variable oxidation states. Transition metals have partially filled d orbitals. Partially filled d orbitals, so they can easily withdraw the electrons from the reagents or give electrons to the, I'll repeat this thing. Transition metals have partially filled d orbitals, so they can easily withdraw electrons or give electrons. Question number 5. Which property of transition metals enable them to behave as catalyst? High melting point, high ionization enthalpy, alloy formation, or variable oxidation states? The right answer, variable oxidation states. Transition metals, they have partially filled d orbitals. They have partially filled d orbitals, so they can easily withdraw electrons from the reagents or they can easily give electrons to them, depending on the nature of the reaction. So they also have a tendency to show large number of oxidation states and ability to form complexes, which makes them a good catalyst. That means D is the right answer. Hope you got that. Let's move to the next question now. Question number 6. In the two tetrahedral structures of the trichromate ion, which of the following is true? 4 CRO bonds are equivalent in length, 6 CRO bonds are equal in length, all are equivalent in length, or all are non-equivalent in length. See, the dichromate dianion consists of two tetrahedral sharing an oxygen at the center, which is given by this one. Now, the chromate ion has the tetrahedral structure. The 6 terminal bonds in the dichromate ion have the same bond length. This one. This is having 160 pm, and these are the two ones. This is having 190 pm. The 6 terminal bonds, so all of these are having this 1, 2, 3, 4, 5, and 6. They are having the same bond length of 160 pm, whereas these two bond lengths are 190 pm. So the 6 terminal bonds in the dichromate ion have the same bond length as 160 pm due to resonance. Here, all the 6 CRO bonds are equal. So option B stands to be the right answer. Hope you got that. Next is question number 7. 1 mole of liquid A and 2 moles of liquid B make a solution having the total vapor pressure of 40 torr. The vapor pressure of A and B are 45 torr and 30 torr respectively. The above solution is an ideal, shows positive deviation, negative deviation, maximum boiling, azeotrope. Which of the following is correct? The right answer to the question, the above solution is showing a positive deviation. Let's look. If the actual pressure is less than the expected pressure, then the solution will show a negative deviation. Actual pressure is less than the expected pressure, then the solution will show the negative deviation. If the actual pressure is more than the expected, it will show positive deviation. If the actual pressure is more than the expected one, so solution will have the positive deviation. Now, if they are equal, they will be ideal. Expected pressure, so solution will be ideal in this case. So over here, let's see, you have the concentration of A as 1 mole of A and 2 moles of B, so 1 upon 3. And XB is this much, 2 on 3. So the total pressure is the A's pressure multiply the A's concentration plus B's multiply P's concentration. This is equal to 45 torr given 1 by 3. And this is the second one is 30 torrs multiply 2 by 3. So this is 15 plus 20, that is equal to 30 torr. But the actual pressure, that is the solution, is having 40 torr. This is actual pressure is more than the expected pressure. That means expected pressure 40 torr is more than the expected. Sorry, this is actual pressure. That is 40 torr is greater than the expected one, which is 35 torr. So that means the solution will show positive deviation. So you have the option as the right answer, this one. Hope you understood that. Let's move to the next question, number 8. Which of the following would not be a good choice for reducing nitrobenzene to aniline? Let's read all the 4 options. These are the 4 options which are given to you. And among all of them, you have the first one, that is LiAH4. This is not a good choice for reducing nitrobenzene to aniline. When nitrobenzene reacts with Li, this is question number 8. Which of the following would not be a good choice for reducing nitrobenzene to aniline? This is, let's write it properly. This is lithium aluminium tetrahalide, hydrogen nickel, iron hydrochloric acid, tin, or hydrochloric acid. Out of these options, the first one, lithium aluminium tetrahalide, this is the right answer. This is not good choice for reducing nitrobenzene to aniline. Now, why is that? When nitrobenzene, it reacts with the lithium aluminium tetrahalide, it does not transform itself to amine. Instead, another product is formed. So it does not transform itself to the amines. Instead, another product, that is Instead, azobenzene is formed. So this reagent will not be a good choice for converting nitrobenzene to amine, and hence this is the right answer to the question. Hope you understood this. Next is question number 9. The molality of a dilute solution is doubled. The value of the molar elevation constant Kb will be, how it will be changed. See, when the value of the molar depression constant Kf, wait, value of molar depression constant, that is Kf, is constant for a particular solvent, it does not depend on the molality of the solution. Thus, it will be unchanged when molality of the dilute solution is doubled. No effect will be there. So it will be unchanged. Option D is the right answer. Value of the molar depression constant is constant for a particular solvent. Is constant. So whatever the however the modality of the dilute solution is doubled or like halved or whatever, it will not change. Hope you got that. Next is question number 10. Hydrolysis of sucrose is called inversion or hydration, esterification, or sponification. The right answer to the question, it is called hydrolysis of sucrose is called inversion. Hydrolysis of sucrose give one molecule of glucose and fructose. And this process is called inversion. Okay. So we have first option as the right answer. Number 11, which one of the following has the lowest pKa value? Out of these options, all right. The one which is having the NO2 group, this is option B. As NO2 group, this is an electron withdrawing group. So removal of electrons is very easy from that group. That means this is high in acidic nature. So acidic nature is high for this. That gives it a lower because the pKa is inversely proportional to the acidic strength. So more is the acidic strength, lower will be the pKa value. That makes V option to be the right answer. Hope you understood that. Next is question number 12. Which one of the following cell was used in Apollo space program? Mercury cell, Daniel, H2O2 fuel cell, or the dry cell? The right answer to the question, this is H2O2 fuel cell. The product for this is H2O. This was used for drinking by the astronauts. This gave water, which was this fuel cell gave water as the product, which was used by the astronauts for drinking purposes. And this is the right answer, option C. Next is question number 13. The following experimental rate data was obtained for a reaction carried out at 25 degrees Celsius. A, gaseous state, B, A and B both in the gaseous state, they react to give C and D in the gaseous state only. So this is the initial, initial concentration of A and B and the initial rate. This is the one. What are the orders with respect to A and B in this? So these are a few of the options. You have to choose the right order for this. Number 13, the following experimental rate data were obtained for a reaction which is carried out at 25 degrees Celsius. A and B in the gaseous state react to give you C and D in the gaseous state. This is the initial concentration of A, initial concentration of B, initial rate is given by this. And you have to find out the order with respect to A and B. The given options are these four. All right. So first thing, the rate of the reaction is given by the formula K into concentration of A power N, concentration of B power M, where N and M are order with respect to A and B. So first thing, let's change the concentration of A and keep B constant. So the two rates in this case, R1 and R2, will be given by, this is K into the concentration of A. This is 3 into 10 power minus 2. raised to power n, and the concentration of B 4.0 into 10 raised to power minus 2 power m. This is given by 1.89 into 10 power minus 4. Similarly, the rate 2 is equal to K into the concentration, which is this, power n. Here is 6. This one. So multiplied by 4 into 10 power minus 2 power m. This is equal to 7.56 into 10 power minus 4. Let's divide both of them. You have R1 upon R2. From here, if I divide this thing will cancel, this will cancel, and here will be 3 upon 6 power n. This is equal to, when I divide 1.89 to this, I'll get 1 by 4. So here you have, this will be 1 by 2 raised to power n is equal to 1 by 4, which can be written like this. This gives you n is equal to 2. Now, I got the order of this A. So now let's go for finding B. M. Now let's change P and keep A's concentration constant. So in the first case, you will have R1 is equal to K into 3 power this raised to power n, and here this concentration is 2 into 10 power minus 2 raised to power m. This is equal to 1.89 into 10 raised to power minus 4. Similarly, you have R2 is equal to K. Here A is changing, A is constant, 3 into 10 power minus 2 raised to power n. This is 4 into 10 raised to power minus 2 raised to power m. This is equal to, again, the same. So let's divide them. You will have, in this case, R1 upon R2, K will cancel, this thing will cancel, and you will have 2 by 4 power m is equal to 1 upon 1. So you have 1 upon 2. This is equal to, I will say here, 2 upon 2 raised to power 0. That gives you m is equal to 0. Therefore, the order of the reaction with respect to A and B will be order of reaction with respect to A and B is given by, this is for A, this is n is equal to 2. So this is second order. And for B, you had m is equal to 0. So this is 0 order. So this is second order and 0 order respectively. Now let's check with the options. We have C as the right answer. Hope you understood that. Let's move to the next question. Question number 14, the magnetic moment of NiCl4 2 minus, where the atomic number of nickel is 28, is which of these options? Okay, let's solve this. See, in the paramagnetic tetrahedral complex, NiCl4 2 minus, the nickel is in +2 oxidation state. And the iron has oxidation state, and this iron has the electronic configuration, which is given by 3d8. The hybridization scheme for this will be, question number 14, the magnetic moment of NiCl4 2 minus is, the atomic number of nickel is 28. It's given over here. And okay, so in the paramagnetic and the tetrahedral complex, NiCl4 2 minus, nickel is in +2 oxidation state. And the iron has the electronic configuration, nickel iron has the electronic configuration of 3d8. And the hybridization scheme will be something like this. So nickel 2 plus, this will first of all have the argon with the atomic number of 18, and then it will be 3d8. It's given by like this. This is 3d. 1, 2, 3, 4, 5, and 2, 4, 6, 7, and 8. And 4s and 4p, they are empty. like this. And if I talk about NiCl4 2 minus, this will be given by same thing. So here you have the 2, here you have the 2, here you have the 2, and this and this. So the next one, this is and this. No, wait. This is actually in the Cl4 minus, so it will be, let it be dotted. Here will be like this. So something like this. This is sp2 hybrid orbitals. So what you had to find out was magnetic moment of this. This is given by root of n into n plus 2. Here n is equal to 2. So this is equal to 2 into 4, that is root 8. Or if I find out the value, this is 2.82 bm. Let's check out with the options. You have B as the right answer. Hope you understood that. Next is question number 15. Assertion says proteins are polymers of alpha amino acids connected by a peptide bond. Reason says the tetrapeptide contains 4 amino acids linked by 4 peptide bonds. So when I look at the assertion, the proteins are polymers of alpha amino acids connected by the peptide bond. This is absolutely right. And the reason tetrapeptide contains 4 amino acids linked by 4 peptide bonds. This is also correct. A tetrapeptide contains 4 amino acids linked by 4 peptide bonds. So number 15, assertion says proteins are polymers of alpha amino acids connected by the peptide bond. The reason is a tetrapeptide contains 4 amino acids linked by 4 peptide bonds. The assertion is right. Proteins are polymers of alpha amino acids connected by the peptide bond. This is right. And but the reason, a tetrapeptide contains 4 amino acids linked by 3 peptide bonds. Instead of 4, it should have been 3. So assertion is correct, but the reason is false. So you have option C as the right answer. Hope you understood this. Next is question number 16. Assertion for a zero order reaction, the unit of rate constant and the rate of reaction are same. The reason is the rate of reaction for zero order reaction is independent of the concentration of the reactant. Here, both of them are correct. Assertion is correct and reason is the correct explanation of the assertion. Rate of zero order reaction does not depend on the concentration of the reactant. Therefore, the unit for both rate of reaction and the rate, they are same. So you have first option. This is the right answer. Hope you understood that. Next is question number 17. Acetic acid, but not formic acid, can be halogenated in the presence of red P and Cl2. The reason is this: acetic acid is a weaker acid than formic acid. Okay, if I this assertion, this is right. Acetic acid, but not formic acid, can be halogenated in the presence of red P and red phosphorus and Cl2, that is chlorine. This is true. And the reason, acetic acid is a weaker acid than formic acid. This reason is correct, but this is not the correct explanation of this assertion. So you have assertion is correct, reason is correct, but reason is not the correct explanation for the assertion. That gives you B option. So this is the right answer to the question. Hope you got that. Next is question number 18. Trans CrCl2OX2 3 minus shows optical isomerism. Optical, the reason says the optical isomerism is common in octahedral complexes involving bidentate ligands. Question number 17, assertion says acetic acid but not formic acid can be halogenated in the presence of red phosphorus and chlorine. The reason says acetic acid is a weaker acid than the formic acid. Here this assertion is right. Reason is also right, but this is not the correct explanation for the assertion. The reason is not the correct explanation for the assertion. See, acetic acid is halogenated in the presence of red phosphorus and chlorine, but not formic acid because it doesn't have the alpha hydrogen atom. It doesn't have alpha hydrogen atom. The loss of the loss of the proton becomes comparatively difficult in comparison to the formic acid. Therefore, acetic acid is a weaker acid than the formic acid. So both of these are correct, but this is not the correct explanation for the assertion. That makes the B option to be the right answer. Hope you understood that. Next is question number 18. It says trans CrCl2OX2 3 minus shows optical isomerism. Optical isomerism is common in octahedral complexes involving bidentate ligands. If I look at these, the assertion is not correct. This doesn't show optical isomerism. The assertion is wrong, but the reason this is true, this is right. See, optical isomers are mirror images that cannot be superimposed on each other. Therefore, you have cis CrCl2OX2 3 minus. This one is chiral, and trans CrCl2OX2 3 minus. This one is symmetrical and not optically active. See, look over here. Here you have a CH2. Question number 18, assertion says trans CrCl2OX2 3 minus shows optical isomerism. No, this doesn't show optical isomerism. This is incorrect. Optical isomers are the mirror images that cannot be superimposed on each other. Therefore, cis CrCl2OX2 3 minus is chiral, and trans CrCl2OX2 3 minus is symmetrical and not optically active. Therefore, the reason this is wrong. Sorry, the assertion is wrong. And let's look at the reason. It says optical isomerism is common in octahedral complexes involving bidentate ligands. This is absolutely right. See, let's look at these two examples to understand the problem carefully. So now look at these two examples over here. Looking at this example and this one, you can easily see that optical isomerism is common in octahedral complexes which are having bidentate ligands. So these are the two examples for that. Hope you got that. So let's see the right answer to the question. This is assertion is false, but the reason is true. So you have the D option as the correct answer. Hope you understood this. Next is question number 19. You are moving to section B now. A bit higher level questions will be coming up. Now, this is a choice question. It says, or what should be the signs, positive, negative for E cell and delta G naught for a spontaneous redox reaction occurring under standard conditions? Second, you have to state Faraday's law of electrolysis. Okay, let's go with the first one. Here you have what should be the signs for these two values for spontaneous redox reaction occurring under the standard conditions. See, delta G naught for redox reaction should be negative for a reaction to occur spontaneously, as the delta G naught is given by minus N F E naught. So E naught should be positive for redox reaction, spontaneous redox reaction. All right, hope you're clear with the first one. Now the second one, Faraday's law of electrolysis. It states that the amount of chemical change being produced by a current at an electroid interface is proportional to the quantity of the electricity used. Let's say, so Faraday's law, it states that amount of chemical change being produced by a current at an electrode-electroid interface is proportional to the quantity of the electricity. So now let's move to the second part or part of the question. You have this equation, this numerical over here. Let's solve this. It says you have to calculate the EMF of the following cell at 298 Kelvin. This is iron solid Fe2 plus. This is having this concentration, and this at 1 bar platinum. Fine. We are given that the voltage of the cell is 0.44 volt. So all these things are given to you. According to the question, there will be two reactions. First is at anode, you will have iron will lose two electrons to make ferrous iron, and at the cathode, the hydrogen will gain two electrons to make hydrogen gas, and the overall reaction will be given by iron plus 2H plus. It will give you ferrous iron plus hydrogen gas. Now, according to Nernst equation, you have E is equal to E naught of cell minus 0.50591 upon N log of concentration of ferrous divided by the concentration of hydrogen square. Here N is equal to 2. So E will be given by, this is given as this, and 0.0591 divided by 2 log of this is 0.01 divided by 1, and this is equal to 0.44 divided by, let it be like this only, and this is equal to log of 10 raised to power minus 2. So this will be 0.44 minus 0.591 divided by 2 into minus 2 log of 10. Log 10 is equal to 1. So this is into minus 2, or this will be equal to 0.44 plus 0.0591, that is equal to 0.4991 volt. So this is the right answer to the question. You had to calculate the EMF. This is equal to 0.4991 volt. So this is the right answer to the question. Hope you got that. Let's move to the next question, number 20. What happens to the rate constant K and the activation energy EA as the temperature of the chemical reaction is increased? You have to justify your answer. See, as the temperature of the chemical reaction is increased, rate constant as temperature increases, rate constant K also increases, whereas activation energy decreases. According to the Arrhenius equation, you have K is equal to A into E power minus EA upon RT. So the rate constant K increases exponentially with temperature. So this is the right answer. Just we have what happens to the rate constant and the activation energy. We have just discussed that. Hope you got that. Let's move to the next question. Number 21, which of the following species cannot act as a ligand? You have to give reason for this. So these are the options given to you, and which cannot act as a ligand. Out of this, ammonium ion, this cannot act as a ligand because it doesn't have any lone pair of electrons, which it can donate to the central metal ion. See, this is having N, H, 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 and H over here. This N is positive charge because it is one extra H over here. So it doesn't have any lone pair of electrons that it can donate to the central metal ion. Therefore, this cannot act as a ligand. Next, the complex, this one is red in color. You have to give the IUPAC name of its linkage isomer. Okay, the complex. This is the complex. This is red in color. The IUPAC name of its linkage isomer. So linkage isomer of the given compound is this is CONH3 5ONO. This IUPAC name is pentaamine because this is having this is coming 5 times. This is pentaamine nitrito O cobalt 3. So this is the right answer. This is the IUPAC name for this linkage isomer. Hope you understood that. Let's move to the next question. Question number 21. Which of the following species cannot act as a ligand? You are given these choices. You have to give reason for the same. Out of the given options, ammonium ion cannot act as a ligand. See, ligands donate electron to the central atom. Or they can have the lone pair of electron to donate and form a bond between the ligand and the central atom. Ammonium is something like this. This is having positive charge over here. So it cannot donate any pair of electron and form bond between the ligand and the, it cannot donate any electron to the central atom. So it doesn't form any ligand. It cannot act as a ligand. So ammonium is the right answer to the question. The B part, the complex, this is red in the complex, this compound is red in color. You have to tell the IUPAC name for the linkage isomer. This is the complex which is given to you. CONH3 5NO2 Cl2. This is red in color when it is present in the hydrated form. Red in color when it is present in hydrated form. It absorbs moisture and turn into the red color. Now its linkage isomer will be given by, here is NH3 5NO2 Cl2. Linkage isomer will be CONH3 5ONO Cl2. This is pentaamine O nitrito O nitro cobalt 3 chloride. And this one pentaamine N nitro cobalt 3 chloride. So this is the linkage isomer for the same. This is what was asked for, and the IUPAC name I have just mentioned. This one. Hope you're clear with this. Let's move to the next question, number 22. Why is the boiling point of O-dichlorobenzene higher than P-dichlorobenzene, but melting point of para isomer is higher than ortho isomer? Okay. See, the melting point of P-chlorobenzene, melting point of P-chlorobenzene is higher than orthochlorobenzene because because of its closed package structure, which has higher intermolecular forces of attraction. That is why the amount of temperature required to break down the bonds while the boiling point of the orthochlorobenzene is high. Next is question number 22. Why is the boiling point of O-chlorobenzene higher than P-chlorobenzene, but melting point of para-isomer is higher than ortho-isomer? All right. See, the melting point of P-chlorobenzene is higher than O-chlorobenzene because of its close packed structure, which have high intermolecular forces of attraction. That is why high amount of temperature is required to break down the bonds. While the boiling point of O-chlorobenzene is high than the para-chlorobenzene because of the high dipole interaction present at the ortho position. It is there is a great dipole forces of attraction between the carbon and the chlorine atom, which results into high boiling point as compared to the p-chlorobenzene, which has the zero dipole moment. See over here, this is chlorobenzene here. Let's write. So this is ortho chlorobenzene over here and here. So this is having the higher boiling point than the para chlorobenzene. All right. Hope you are clear with this. Let's discuss this once again. Orthochlorobenzene has higher boiling point than parachlorobenzene because dipole moment of this is maximum and the dipole-dipole interaction is maximum than the parachlorobenzene. Whereas parachlorobenzene has the higher melting point because than that of the ortho and the para and the ortho isomer of it because of the greater symmetry that fits in the crystal better as compared to ortho and the meta isomer. So hope you are clear with this. Let's move to the next question then. Question number 23. For the pair phenol and cyclohexanol, answer the following. Why is phenol more acidic than cyclohexanol? Cyclohexanol is less acidic as compared to phenol because phenol is an aromatic compound, while cyclohexanol is cyclic ring structure containing hydroxyl group. In phenol, benzene ring is having double bond. Benzene ring is having the double bond showing sp2 hybridization because of more S character. This one is more acidic. Hope you're clear with this. Now the second one, you have to give one chemical test to distinguish between the two. I'll take the bromine water test. Bromine water test. This can be used to distinguish between the phenol and the cyclohexanol because phenol reacts with bromine water and gives tribromophenol, while cyclohexane does not. Cyclohexanol does not react with bromine water. See over here, this is your phenol. So this is oxygen lone pairs will be this, and you are having bromine water. This gives me this structure. OH, Br, Br, Br. This is tribromophenol. Right? So while cyclohexanol, it does not react with the bromine water. So you got your answer, right? Let's move to the next question. Then question number 24. You have to draw the Zwitter ion structure for the sulfanilic acid. So let's go to this question first because you're having a choice over here. Either you can perform this or this question. So very first question, you have to draw this ion structure. Let's draw this. You have a benzene ring over here. Here is NH2. Wait. Like this. And you have S, double bond O, OH. And NH2 over here. The This is your sulfonilic acid, and the zither ion for structure for the same will be this one. Here is S double bond O, and oxygen will have a negative charge over here, and NH3 plus will be over here. Hope you got that. Now, the second one, how can the activating effect of NH2 group in aniline be controlled? This effect of NH2 can be controlled by using the Friedel-Crafts method. That is by alkylation and acetylation process, because nitrogen of aniline required a positive charge and hence can act as a strong deactivating group. Let's understand this through this equation. So here is your NH2 CH3 COCl. This is pyridine. You will have here NHC CH3 double bond O. Lone pair will be over here plus HCl. This is acetanilide. So this activating effect of NH2 group can be controlled by acetylation of NH2 group. Hope you're clear with this. Now let's move to the B part, because this question was in choice. Now let's move with the second option that you can carry out. So here's the first one. You have to complete the required reaction. The main product formed will be. This is your N2 plus Cl minus. This will be CH3CH2OH. This will be benzene will be formed. Along with ethanol, and this. So this is the complete reaction, and yeah. Now the second one, you have to convert the bromoethane to propamine. The second one, the B part, you have to convert bromoethane. This is CH3, CH2, Br, bromoethane in the presence of alcoholic potassium cyanide. This will give you CH3, CH2, CN. This is propanitrile. Again, in the presence of lithium aluminium tetrahalide, it will give you CH3, CH2, CH2, NH2. This is propanamine. So this is the complete reaction for the both of them. Hope you are clear with this. Let's move to the next question now. 25, give the reaction of glucose with hydrogen cyanide. Presence of which group is confirmed by this reaction? Let's complete the reaction. Reaction of glucose with hydrogen cyanide. This is glucose, CHO. This 4 CH2OH. On reaction with hydrogen cyanide, this will give me, here will be CN, here will be OH attached, and the rest will be CHOH 4 CH2OH. Now this reaction confirms the presence of the carbonyl group. This group. Carbonyl group. Right, in the glucose. So hope you're clear with this. This is the reaction of glucose with hydrogen cyanide. And this particular experiment, this particular reaction confirms the presence of the carbonyl group in the particular compound. Hope you're clear with this. Next is question number 26. So for this reaction, calculate the rate of reaction, the rate of disappearance of nitrogen oxide, dinitrogen oxide, 5 gram is this much. This is the B part. I'll talk about that later. First of all, start with the very first part of it. So let's complete the reaction. You have N2O. This is in the gaseous 5, N2O5. This is in the gaseous state. Question number 26. For the reaction 2N2O gives this at 318 Kelvin, you have to calculate the rate of reaction. The rate of disappearance of this is this much. So let's write down the reaction once. You have this reaction N2O5, 2 molecules of it. It gives you 4NO2 plus oxygen gas at 318 Kelvin. Yeah. So minus T N2O5, the rate of change of this is equal to, it's given, the rate of reaction is this much, 1.4 into 10 power minus 3 meters per second. Also, the rate of reaction is given by minus 1 by 2 into D N2O5 upon dt. So this is equal to 1 by 2 into 1.4 into 10 raised to power minus 3. This is 0.7 into this meters per second, or you can write it as 10 into this meters per second. Hope you are clear with this. So rate of reaction we have calculated. The answer is 7 into 10 power minus 4 meters per second. Second one, for the first order reaction, derive the relationship T 99% to 2T 90%. For the first order, I'll erase the screen. So for the first order kinetic, we know that T is equal to 2.303 upon K log of A upon AX. For first order reaction. So, or this can be written as 2.303 upon K log of concentration of A naught upon this. Now, for the 99% completion, you have the A's concentration as A minus 99% of A. This is equal to A minus 99 and upon A, or this will come out to be, this will be 0.01 A. All right. So you have T 99% is equal to 2.303 upon K log of A upon 0.01 A. Or this will be equal to 2.303 K log of 1.01, or this is 2.303 upon K log of 100, that is equal to actually 10 power 2, or I can write it like this, log 10 power 2, or this will be 2.303 upon 3 into 2 log 10, that is equal to 1. So this will give me T 99% is equal to 2 into 2.303 upon K. This is 1. And now for the 90% completion. This T 90% will be equal to 2.303 upon K log A upon 0.1 A. Right? See over here, same thing. This concentration, let's find it again. The concentration A, this will be given by A minus 90% of A. This is equal to A minus 90 upon 100 of A. This will be equal to 10 upon 100 A, or this is equal to 0.1 A. Hope you are clear like how I got this now. So T 90%, this is equal to 90% is 2.303 upon this, and this will be log 10. Log 10 is equal to 1. So this is 2.303 upon K. Let's say this is 2. Now from both the equations, this 1 and the 2. Both of these equations, let's divide them. You will have T 99% upon 90%. This is equal to 2 upon 1. That's it. Or what you had to find out, T 99% is equal to twice of T 90%. This is what we needed to derive, right? For the first order reaction, derive this relationship and done. Hope you're clear with this. Let's move to the next question then. Question number 27, on the basis of crystal field theory, write the electronic configuration of D5 ion with a strong field ligand for which delta naught is greater than P. There's a B part also. We'll talk about that later. First of all, in regard to the first question, it is the magnitude difference in the energy between the two set of d orbitals, that is T2G and EG. Electronic configuration of D5, electronic configuration of Number 27, on the basis of crystal field theory, write the electronic configuration of T5 ion with a strong field ligand for which delta naught is greater than P. All right. See, if delta naught is greater than P, it becomes more energetically favorable for the fourth electron to occupy a T2G orbital with the configuration T2G 5 EG naught. Ligands which produce this effect are known as strong field ligands and form low spin complexes. For example, you have a tetracyanonucleate ion. Here, sorry, this is negative. Here, the CN is a strong field ligand. Hope you got that. So now the next part, the B part of the question is this is, okay, NiCO4, this is tetrahedral geometry, while this is having a square planar, yet both exhibit dimagnetism. Okay, you are having the atomic number of nickel is given to you as 28. Fine. Let's start with the tetracyanonucleate. So this is the B part. You know, the nickel is having the atomic number as 28. So this is given by argon. And then this is 3D8, 4s2. Nickel plus, 2 plus. This will have 3D8. Argon 3D8 because the 4s0 will be there. 2 electrons have been removed. So nickel cyanide, tetracyanonucleate. This is a strong field ligand given by this. So here you have 1, 2, 3, 4, 1, 2, 3, and a single over here. Empty and empty. And over here, this will be, see, this will shift. So this will be given by complete, 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 and nothing. No. So this is D, sp2 hybridization showing square. Planar geometry. All electrons are paired, so it's diamagnetic in nature. All electrons are paired over here. So are paired. So it's showing diamagnetic nature. So let's move with the next one. That is NiCO4. The same thing. NiCO4. Okay. So this is the one. And nickel, you know, of course, this is having the atomic number as 28. So here will be argon, there 3D8, 4s2. Valency of nickel, because it is not having any oxidation number. So over here, the valency of nickel is 0. And it will be denoted like this. The orbitals will be completed like this. It will be 1, 2, 2, 2 electrons, and a single and a single. And this is 4s, this is 3D. This will be, okay, wait. This is like this. 4p. Right. Now, this whole compound, like after the electron shifting, again, it will be moved over here. And 1, 2, 3, 4, and 5. Here will be XX, and this is showing sp3 hybridization. Therefore, it's having tetrahedral geometry. All the electrons are paired. All the electrons are paired. Therefore, it's diamagnetic in nature. Hope you got that. So this completes your 27 question, which is having two parts, A and B. Hope you got that. Let's move to the next question now. Question 28, illustrate the Sandmeyer's reaction with an equation. What is Sandmeyer's reaction? In benzene, if I talk about the benzene diazonium chloride, which is given by C6H5N2Cl. The chloride, bromide, and the cyanide nucleophiles can easily be introduced in the ring in the presence of the copper 1 ion. This reaction is called the Sandmeyer's reaction, and it is illustrated such that ArNX2, this is benzene diazonium salt in the presence of CuCl2, HCl. It gives you ArCl plus nitrogen. Okay, ArCl2 nitrogen, this is aryl chloride. In the presence of Cu2Br2 cuprous bromide, it gives you HBr. That is, it gives you Ar. In the presence of HBr, it gives you ArBr plus N2. This is aryl bromide. And CuCN in the presence of potassium cyanide, it gives you ArCN. This is aryl cyanide. So this is the reaction for the Sandmeyer's reaction. Hope you got that. Now the second one, explain why CH32NH is more basic than CH3N in aqueous solution. Okay. See, in the aqueous solution, the substituted ammonium cation gets stabilized not only by the electron releasing effect of the alkyl group, but also by the salvation with water molecule. The greater the size of ion, lesser will be the salvation. Greater size of ion, lesser will be salvation. And less stabilized will be the ion. Less stabilized will be the ion. So the order of stability of ions will be given as the order of the stability of the ions. Greater the stability of the substituted NH4 plus cation, stronger should be the corresponding amine. Therefore, the order of the basicity will be given as order. Basicity will be given as first of all, you will have primary, then secondary, and then tertiary. Looking at that from the given options, okay, that is why this is more basic than CH3 to NH is more basic than CH3 3N. Hope you got that. Now let's move to the next question. Number 29, give reasons for any three of the following observations. First one is pentaacetate of glucose does not react with hydroxamine. Second, amino acids behave like salts. Third, water-soluble vitamins must be taken regularly in diet. And the last one, the two strands in DNA are complementary to each other. This is a very important question, actually. Okay, let's start with the very first one. The pentaacetate of glucose does not react with hydroxylamide. The pentacetate is having the formula as C16H22O11, and due to the absence of the aldehyde group CHO, this does not react with the hydroxamide. That's OH NH2. Hope you got that. The next one, amino acids behave like salts. Amino acids behave like salts rather than simple amines or the carboxylic acids. This behavior is due to the presence of both acidic, that is carboxylic group, and the basic group, which is your amino group in the same molecule, right? The next one, water-soluble vitamins must be taken regularly in diet. B group vitamins and vitamin C are water-soluble. B group vitamin and vitamin C are water-soluble, must be supplied regularly in diet because they are readily excreted in urine and cannot be stored, except vitamin 12 in our body. Okay, so got that. Next one, the two strands in DNA are complementary to each other. The two strands are complementary because let's come here. This is the D part. Because the hydrogen bonds are formed between specific pair of bases. Adenine forms hydrogen bonds with thymine, and cytosine forms hydrogen bonds with guanine. That is why the two strands of DNA are complementary to each other. Hope you got the question number 29 as well. Let's move to the next question. Question number 30. It has two parts, two choices actually. You can attend either of them. The first one says the first question itself is having three questions, and the second one is having two questions. Let's go with the first part. It says, why is CO bond length in phenols less than those in the methanol? The CO bond, the carbon oxygen bond length, which is approximately 136 pm in phenol, is slightly less than in that one in methanol. So methanol is having the greater bond length. This is due to the partial double bond. This is due to the partial double bond character on account of conjugation of unshared electron pair. Unshared electron pair of oxygen and with aromatic ring and sp2 hybridized state of carbon to which oxygen is attached. Hope you got that. So now let's move to the second part. Arrange the following order in the following in order of increase in the boiling point. This is 1 mark question, so no need to, you shouldn't go for any explanation. You can directly write down the answer. This is the second part. This was the first part. So the second part carries the answer as first is in butane is having the least boiling point, and then is ethoxy ethane and butanol, then butanol. So this is the right order in of increasing boiling point. The last one for the A section, A part. How can phenol be prepared from anisole? You have to give the reaction for that. Let's prepare anisole, phenol from anisole. So anisole on reaction with hydrogen iodide gives phenol, and CH3I as main product. Let's go for the reaction. So here is your ring. This will be OCH3 hydrogen iodide, and this is heated. You will get phenol along with CH3I. This is the chemical reaction for that. Hope you are clear with the A part. Now this question is in the choice. The second part of the question says, give mechanism of the following reaction. So this is the reaction. You have to give the mechanism for the whole reaction, like how does this take place. I'm going to clear the screen now. So these are this is your reactant in the presence of sulfuric acid at 413 degree 1413 Kelvin. It gives you diethyl ether. Now let's go for the mechanism. The formation of ether is a nucleophilic bimolecular reaction. SN2 involving attack of alcohol molecule on protonated alcohol. Attack of alcohol molecule on protonated alcohol. All right. So let's go with the mechanism. The very first, you have CH3, CH2, OH. Sulfuric acid will give the hydrogen ions, two lone pairs on oxygen. So what will happen? This hydrogen will get attached over here. It will be CH3, CH2, OH. Here will be one H plus, and yeah, this will be attached, and two lone pairs over here. All right. So now next, this with CH3, CH2, OH, H. Now this will break out. This part will break out. Here's this is oxygen is carrying the positive charge over here, and this both will get attached over here. Now you will have, this will yield you CH3, CH2, O, CH2, CH3, H. This will get the positive charge plus water. Right. This is your second step. This was your first step. Now again, this will be, this will give me CH3, CH2O, CH2, CH3, and this will be liberated now to give you H plus. And see, over here, this was H plus. So from sulfuric acid, one H was removed. It was HSO4 negative ion. Now this hydrogen ion gets attached to it. HSO4 negative. It gives you sulfuric acid back. Hope you're clear with this. Now let's go with the second part of the question. Illustrate hydroboration oxidation reaction with an example. Hydroboration oxidation reaction. I'm gonna clear the screen again. So diborane reacts with alkenes to give diborane reacts with alkenes to give trialkyl boranes as addition product. This is oxidized to alcohol by hydrogen. This is oxidized to alcohol by hydrogen peroxide in the presence of aqueous sodium hydroxide. This is oxidized to alcohol by hydrogen peroxide in the presence of aqueous sodium hydroxide. Let's see the chemical reaction. CH3, CH2, CH2. This is propene when reacts with diborane. This gives you CH3, CH2, CH3, CH2, and here will be H attached. Here is PH2 attached. This again in the presence of CH3, CH2 gives you CH3, CH2, CH2, 2BH. Again, in the presence of propene, CH3, CH, CH2, you have CH3, CH2, CH2, 2, 3. Yeah, here will be. So again, water and hydrogen peroxide, hydroxyl ions. It will give you 3 CH3, CH2, CH2, OH plus BHO3. This is propanol. 1 propanol. Right. So this is your complete reaction, hydroboration oxidation reaction with an example. Hope you are clear with this. Let's move to the next question then. Everyone, the following questions are case-based questions. Read the passage carefully and answer the questions that follow. Nucleophilic substitution, reaction of haloalkane can be conducted according to both SN1 and SN2 mechanisms. SN1 is a two-step reaction, while SN2 is a single-step reaction. For any haloalkane, which mechanism is followed depends on factors such as structure of haloalkane, properties of the leaving group, nucleophilic reagent, and solvent. Influences of the solvent polarity in SN reaction. The polarity of the system increases with the reactant to the transition state because a polar solvent has greater effect on transition state than the reactant, thereby reducing activation energy and accelerating the reaction. In SN2 reaction, the polarity of the system generally does not change from the reactant to the transition state. Only the charge dispersion occurs. At this time, the polar solvent has a greater stabilizing effect on NU, then the transition state, thereby increasing activation energy and slows down the activation reaction rate. For example, the decomposition for the SN1 tertiary chlorobutane at 25 degrees Celsius in water, dielectric constant 79, is 3 lakh times faster than in ethanol, dielectric constant 24. The reaction rate SN2 of 2-bromopropane and NaOH in ethanol containing 40% of water is twice lower in the absolute ethanol. Hence, the level of the solvent polarity have influence on both SN1 and SN2 reaction, but with different results. Generally speaking, weaker polar solvent is favorable for SN2 reaction, while stronger polar solvent is favorable for SN1 reaction. Generally speaking, the substitution reaction of the tertiary alkane based on SN1 reaction in solvents with strong polarity, for example, ethanol containing water. So based on this, you have to answer the following questions. Number one question is, why racemization occurs in SN1 reaction? See, because in the SN1 reactions, carbocation intermediate is formed as a planar molecule which will lead to the D and L form products. So racemization occurs. Let's write it down. Because in SN1 reactions, carbocation intermediate formed is a planar molecule which will lead to form D and L form products. Therefore, the racemization occurs. Now, the B part. Why is ethanol less polar than in water? Because water has two hydrogen bonds which are given like this, which are having the structure. Water is having structure like this. Because of these two hydrogen atoms which are bonded to oxygen, while alcohol like ethanol has one hydrogen atom and ethyl alkyl group bonded to the second one. So here is H and the second one is containing an alkyl group, in this case ethanol. So this is ethanol is attached to it. Okay, so ethanol is less polar than water. Yes, ethanol is less polar than water because here the two hydrogen bonds are attached to the single oxygen atom, while in alcohol, this is one hydrogen atom is attached over here. Hope you got that. Next is, which one of the following in each pair is more reactive than SN2 reaction? So these are the two given, okay, these are the two questions given to you. You have to tell which of the following in each pair is more reactive than towards SN2 reaction. Let's erase the screen. So here is the first one. This one, you have CH3, CH2I and CH3, CH2Cl. Out of these two, CH3, CH2I undergoes SN2 reaction faster than CH3, CH2Cl. And for the second one, mm, the second one, this compound, let's write it over here. Here is Cl, and this is or CH2Cl. This is cyclohexyl chloride. This is a secondary halide. And this the second compound is cyclohexyl methyl chloride. This is primary halide. Therefore, this undergoes faster SN2 reaction. Faster SN2 reaction in comparison to the secondary halide. Hope you got that. So we are done with the first part of the question. Hope you are clear with this one. Now let's go with the second part of the question. This is the choice. You can either attempt this question or this question. So let's go with this. Arrange the following in the increasing order of their reactivity towards the SN1 reaction. I'm gonna clear the screen now. So let's look it over here. Increasing order of their reactivity towards SN1 reaction. For the second part, it says arrange the following in the increasing order of the reactivity towards SN1 reactions. Actually, this is a little like it should be SN2 reactions. No, it is SN1 reactions only. I'm repeating the question again. Arrange the following in the increasing order of their reactivity towards SN1 reactions. It's 2-bromo, 2-methylbutane, 1-bromopentane, 2-bromopentane, and the second one is this. Before starting with the question, if I talk about the reactivity of SN1 reactions towards the halides, first of all, the tertiary halides, they are followed by the secondary halides, followed by the primary alkyl halides. This is the order of their reaction. This order is basically based on the stability of carbocations, which are formed after the removal of halide ion. All right. So based on this, what is the correct order for the given one? The first one, this is tertiary. Yes, this is tertiary, and then this is secondary, and this is the primary. So you have the correct order for the first part as this will be 2-bromo, 2-methylbutane, followed by 2-bromopentane, followed by 1-bromopentane. Hope you understood. Now the second part. Let's see. This will be the first one. 1-bromo 3 methylbutane. This is the tertiary halide. Then this is it. Here will be 2-bromo 3 methylbutane, and then you have 2-bromo 2-methylbutane. So this is the correct order, and this is your complete question that you want. Hope you understood that. Let's move to the next question. Question number 32. Rahul set up an experiment to find the resistance of aqueous potassium chloride solution for different concentrations at 298 Kelvin using conductivity cell connected to a Wheatstone bridge. He fed the Wheatstone bridge with AC power in the audio frequency of 550 to 5000 cycles per second. Once the resistance was calculated from the null point, he also calculated the conductivity K and the molar conductivity and recorded his readings over here. Using this data, you have to answer the following questions. Let's go. First one, why does conductivity decreases with dilution? See, the conductivity of a solution is the conductance of the ions present in unit volume of the solution. The number of ions which are responsible for carrying current decreases when the solution is diluted. Ions decreases when solution is diluted. As a result, conductivity also decreases. If number of ions will decrease, conductivity will also decrease. So this is the right explanation. The second one, if the molar conductivity for the infinite dilution of KCl is given by this, you have to calculate the degree of dissociation of 0.01 mKCl. 0.01, this is having the molar conductivity as this much. Sorry, this is the molar conductivity. All right, this is the one. So let's write down what your things are given to you. You are given for the B part. You are given the molar conductivity for the infinite dilution of KCl is 150 s centimeter square per mole, and the molar conductivity for the given dilution of 0.01 mKCl is equal to 141 s centimeter square per mole. Now, as you know, the degree of dissociation is equal to molar conductivity upon the molar conductivity for the infinite dilution. This is equal to 141 upon 150, which gives you 0.94. So the answer to this question is 0.94. Hope you got that. The C part, if Rahul had used hydrochloric acid instead of potassium chloride, HCl instead of KCl, then would you expect the molar conductivity values to be more or less than per KCl for the given concentration? You have to justify your answer. See, if the Rahul would have used HCl instead of KCl, if he would have used HCl instead of KCl, then molar conductivity value would have been higher than for KCl for the given concentration. The reason behind this is that the increase in the molar conductivity of H plus as compared to K plus is that the H plus is having higher value of the molar conductance in the aqueous solution because proton is transferred from one water molecule to another hydrogen bonded chain of water molecules, right? So it will increase. Next, it is having the C part is in the choice. It's saying Amit, a classmate of Rahul, repeated the same experiment with acetic acid solution instead of KCl solution. Give 1 point that would be similar and one that would be different in his observations as compared to Rahul. Okay, Amit, he repeated the same experiment with the acetic acid. You have to 1 point which is similar and in his observations and 1 point which is different. Okay, Amit observed if Amit used CH3COOH COOH instead of KCl, he observed that molar conductivity will increase this time. Molar conductivity increases with dilution because specific conductivity decreases with dilution. KCl is a strong electrolyte and completely dissociates into their respective ions. Complete dissociation into the respective ions, while the acetic acid CH3COOH, this is a weak electrolyte and do not complete the dissociation. One thing more, the number of ions produced. What is the similarity? This was a difference you can say, and the similarity says that the number of ion produced after dissociation are equal. KCl will give you K plus Cl and CH3COOH will give you CH3COO negative plus H plus. So the number of ions produced after the dissociation, they are equal. This is the similarity and this is the difference between the two. Hope you got that. Let's move to the next question. Next is question number 33. Why is section E? It says, why is boiling point of 1m NaCl solution more than 1m glucose solution? Instead of reading all the questions, see, basically you are having A And A question is having three parts, 1, 2, 3. This is, or you can go for this choice like B part. Either you can attempt this or you can attempt this question. I'll start with the A part. A part, first question, first part. See, the boiling point is directly proportional to the molality and mm, question number 33 of section E, it is having two parts, A or B. There's a choice between A and B. You can do either of them, and each part is having three subparts, 1, 2, 3. So let's start with the A part of the question. First question from that. Why is boiling point of 1 m sodium chloride solution more than 1 m glucose solution? See, boiling point is directly proportional to molality, and it is directly proportional to molality and Van Hoff's factor. Since Van Hoff factor for 1 m NaCl is 2 and 1 m glucose is having the Van Hoff factor as 1, so this is greater. That means the boiling point of sodium chloride is greater. Then 1 m sodium chloride is greater than boiling point of 1 m glucose. Hope you're clear with this. The second part of the question says you have a non-volatile solute X whose mass is 50 gram per mole. When dissolved in 78 gram of benzene, reduced its vapor pressure to 90%. Calculate the mass of X dissolved in the solution. Okay, see, there's a formula. Relative lowering of the vapor pressure is given by, this is second part. Relative lowering of vapor pressure is given by P naught minus Ps divided by Ps. This is equal to Nb upon Na. And you are given in the question that it reduces to 90%. So 90% of P naught, that gives you 0.90 P naught. This becomes P naught minus 0.9 P naught divided by, wait. Divided by P naught, 0.9 P naught. This is equal to now number of molecules of B. This is given by the weight of B divided by its molecular mass. Multiply by, this is 78 upon 78. Here you are given in the question that it is dissolved in 78 gram of benzene and the molecular mass of benzene is also 78.11. So I'm taking it roughly as 78 only. Molecular mass of benzene is equal to 78. Okay, so let's do the calculations now. This is equal to 0.1 P naught upon 0.9 P naught is equal to, this cancels out WB upon weight of V divided by 50, or this is equal to 50 upon 9 is equal to the required weight, that is 5.5 gram. So the answer to the B part of the question, mass of X dissolved is 5.5 grams. Hope you're clear with this. Now the third part, calculate the boiling point elevation for a solution prepared by adding 10 gram of MgSeCl2 magnesium chloride to 200 gram of water, assuming magnesium chloride is completely dissociated. Kb for water is this, and molar mass for magnesium chloride is 95 gram per mole. All right. We know one thing that, let's write it down. We know that delta TB is equal to IKB into M. Now, reaction says magnesium chloride gets reduced to this. So this is having 1 and the 2 moles. So I is equal to 3 over here. Here you have M as WB into 1000 divided by the molar mass of P into the weight of A. All right, so this gives me, let's fill in the values that you have. So you have the weight of magnesium is 10 gram and the weight of water is 200 grams and the molecular mass of MgCl2, this is 95. Let's fill in all the values over here. So this will be 10 into 1000 upon Ma into Wa. This was 95 and this one was 200, right? So this comes out to be, on solving, it will give you 0.526. Now delta TB will be given by, let's use that one. That was equal to I into KB into M. I is equal to 3. Value of KB, it's given in the question, 0.512, and the mass is 0.526. This gives you 0.808 Kelvin. So this is the right answer to the question, 0.808 Kelvin. 0.808 Kelvin. Hope you understood this. Now let's move to the OR. That means you have a choice over here. Why is the value of Van't Hoff factor for ethanoic acid in benzene close to 0.5? Okay. See, in benzene, two molecules of ethanoic acid dissociate to form a dimer. Let's see. This is the B part, ethanoic acid. Two molecules dissociate to form a dimer, something like this, CH3COOH. It gives you this, a dimer. Thus, Van't Hoff factor will be, Van't Hoff factor will be given by I is equal to number of solute after. It will be I is equal to dissociations or associations divided by number of. So B part says, B part first question, why is the value of Van't Hoff factor for ethanoic acid in benzene close to 0.5? See, in benzene, two molecules of the ethanoic acid dissociate to form a dimer. Ethanoic acid, two molecules, they dissociate to form a dimer like this. In benzene, two molecules of ethanoic acid associate to form a dimer. So you have to CH3COOH. It gives you this dimer. Thus the Van't Hoff factor will be given by number of solute after dissociation or association divided by number of solute before dissociation or association. So this is equal to 1 upon 2. So that's 0.5, hence proved. Right? Hope you got that. Next is question number 2. Determine the osmotic pressure of a solution prepared by dissolving this much of potassium sulfate in 2 liters at 25 of solution at 25 degrees Celsius, assuming that potassium sulfate is completely dissociated. Here you have R is this, molar mass of K2SO4 is equal to this. Okay, first of all, you are having a amount of potassium sulfate dissolved is given by 2.32 into 10 raised to power minus 2 gram. Volume of the solution is 2 liters. Temperature 25 degrees Celsius. Let's convert that into Kelvin. So molar mass of K2SO4, this is given by 2 into 39. Sulfate is having 32. And SO4, 4 into 16. This will give you 174 gram per mole. Since K2SO4 dissociates completely to give you these two ions, therefore total ions produced is equal to 3. 2 and 1, total ions 3 are produced. So that means you have I is equal to 3 and pi is equal to ICRT, or here C is equal to 4 upon V. Here C is the concentration, which is given by 2.32 divided by 174. So let's fill in all the values over here. So this pi will be given by I, this is 3, and C is given by 2.32 divided by 174, and volume is 2. Read our gas constant is 0.082 and temperature is 298. So on solving this whole thing, you will get 8 point, I guess everything is written. This is 174. 85.14 divided by 174 into 100, or this is equal to 0.0048, or 4.8 into 10 raised to power minus 3 atmospheres. So this is the right answer to the question, and the right answer 4.8 into 10 power minus 3 atmospheres. Now the third part, when 25.6 gram of sulfur was dissolved in 1000 gram of benzene, the freezing point lowered by 0.512 Kelvin. Calculate the formula for the sulfur. Kf for benzene is this much, atomic mass of sulfur is equal to this much. Okay, let's clear the screen now again. So you have Kf for benzene 5.12 Kelvin kg per mole, and WB, that's weight of solute, mass of solute, 25.6 grams, and for A, this is 100 gram. Delta TF is equal to 0.512 Kelvin. Atomic mass of sulfur, 32 gram per mole. So molecular mass of B is Kf into WP 1000 upon delta TF into WA. This is equal to 5.12 into 25.6 multiplied by 1000 divided by 0.512 into 1000, or this is equal to 131.072 divided by this much. This gives you 256. Now molecular mass of the required molecular mass is given by X into 32. This is 256, right? So you have the number 2 as 256 divided by 32. So the formula for the sulfur will be, formula for sulfur in this case will be S8. Hope you got that. So this is the third question, third part of the question. So we have done both A and B, like whichever suits you, you can perform in the paper. Hope you got that. Next is question number 34. Write the equation involved in Cannizzaro reaction. Number 2, why are the boiling point of aldehydes and ketones lower than that of the corresponding carboxylic acids? Number 3. So again, you have a choice between A and B. You have a choice question. You can attempt any of these. Let's go with the first question. A part, first question over here. It says, why? Write the reaction involved in the Cannizzaro. Write the reaction involved in the Cannizzaro reaction. Okay, fine. So this is the one. You have a formaldehyde over here. Sorry, I have this. See? Of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to study your entrance exam question papers, because you have so many entrance exam question papers along with the detailed PDF solutions at this website. Also, you may download our app. The link is available in the description box. So, students, a very best of luck. Today, we'll be solving CBSE Class 12, Delhi. Set 2 chemistry paper. I'm going to solve the set 2. Set 1 has already been solved and uploaded. Please check out that. And this set 2 is in continuation with the set 1 only. A very best of luck. Here we start with the very first question. It says, consider the following standard electron potential values. This is for ferric Fe3 plus, and this is the second one. You have to find out the cell potential for the redox reaction. See, the cell potential is always given by potential at cathode minus potential at anode. So what is the potential at cathode? It is given 1.51, and for the anode, it is this much. So the difference between the two, this is equal to 0.74 volt. That makes C option to be the right answer. Hope you got that. Next is question number 2. Which of the following ions have the electronic configuration 3d6? Atomic number of manganese is 25, cobalt 27, nickel is 28. So let's discuss the electronic configuration of all of them. Which are the following ions? Okay, it's been talked about the ions. Let's write down the electronic configuration for the ions. First of all, manganese. Manganese exists in the oxidation state of 3. So manganese 3 plus. This is having the atomic number of 25. 3 plus, that means 3 electrons have been removed. Now the electrons remaining are 22 for the manganese. So first of all, you will have argon, which is having 18 electrons. Then it will be followed by 3d4 because 22. So yes, 3d4. And the next one, this is, let's say, okay, nickel. Let's write down nickel first. Nickel plus 3. So after removing 3 electrons, 25 electrons will be removing over here. First of all, argon 18, and then it will have 3d7. Then cobalt. Cobalt is again plus 3. Cobalt is having 27 electrons. So minus 3, 24 electrons will be left. Argon 18, and here will be 3d6. We have written all. Okay, one more thing. The manganese, this is plus, this exists in the +2 oxidation state as well. So this will be like here will be 2 electrons removed. So this will have 23 electrons over here. This is argon 18. So 3d4. Right. So these are the which of the following ions have the electronic configuration of 3d6. This is cobalt 3 plus. Option B is the right answer. Hope you understood that. Next is the question number 3. Which of the following aqueous solution will have the highest boiling point? 1.1 m KCl, 1 m potassium sulfate, 2 m potassium chloride, or 2 m potassium sulfate. More the value of the Van't Hoff factor and molality, more is the boiling point. More is the value of Van't Hoff factor and molarity. More is the boiling point. So which is having, according to here, this is having the highest molality. So you have this is option D. The Van't factor for the K2SO4 is 3, and for KCl is approximately equal to 2, and also the molality is more over here. So option D stands to be the right answer. Hope you understood that. Next is question number 4. It says amides can be converted into amines by the reaction named Hoffman's degradation, or ammonolysis, or carbylamine, or diazotization. The right answer, uh, okay, the right answer to the question is option A, Hoffman's degradation. The conversion of an amide by the action of sodium hydroxide and bromine to primary amine that has one carbon less than the starting amide is known as Hoffman's degradation reaction. Let's write it down. Conversion of an amide by the action of sodium hydroxide and bromine to primary amine that has one carbon less than the starting amide is known as option A, Hoffman's degradation. Hope you understood this. So we have first option as the right answer. Next is question number 5. Which of the following statements is not true about glucose? Um, it is an aldohexose. This is right. On heating with the hydrogen iodide, it forms N-hexane. Correct. It is present in pynorose form. Yes. It gives 2,4-DNP test. This is incorrect. This statement is not wrong, not right. This is incorrect. It gives 2,4-DNP test. This is wrong. Glucose doesn't have an open chain. Glucose does not open chain structure, and hence it doesn't have a free CHO group. Actually, CHO group combines with C5OH to form hemiacetal ring, which is a six-membered oxide ring. Thus, glucose largely 99% exists in cyclic hemiacetal form. And so it does not give the 2,4-DNP test. So this is the right, this is the incorrect statement in the given question. Hope you understood this. Next is question number 6. Assertion says vitamin C does not, cannot be stored in our body. Reason is vitamin C is fat soluble and is excreted from the body via the urine. The right answer is C. Fat. Look at the assertion. Vitamin C cannot be stored in our body. Vitamin C is a weaker soluble vitamin. We cannot store it. This is because it is excreted from the body through the urine. So this is right. It is not. It cannot be stored in the body. And the reason for the same says it's a fat soluble and excreted from the body in the urine. Question number assertion says vitamin C cannot be stored in our body. This is right. This assertion is correct. Reason says vitamin C is fat soluble and excreted from the body in the urine. See, vitamin C is not fat soluble. It is water soluble. So this reason is wrong. Assertion is correct. Vitamin C is a weaker soluble vitamin. We cannot store this because it is excreted from the body via the urine. So this is the right answer to the question. Option C. Assertion is correct, but the reason is wrong. Hope you understood that. Let's move to the next question. Question number 7. The half-life of a reaction is the time in which the concentration of the reactant is reduced to one half of the initial concentration. This is right. This is the half-life of a reaction. Reason says in the first order kinetics, when concentration of the reactant is doubled, the half-life is also doubled. No, this reason is wrong. For a first order reaction, half-life is independent of the initial concentration. For first order reaction, half-life is independent of concentration, or you can say it is independent of the initial concentration. So hope you are clear with this. We have this C as the right answer. Hope you got that. Next is question number 8. Bromination of benzoic acid gives M-bromobenzoic acid. This assertion is right. And the reason says carboxyl group increases the electron density at the meta position. This is wrong. Bromination of benzoic acid gives M. Benzoic. Sorry, this is bromination of benzoic acid gives M-bromobenzoic acid. As COOH is an electron withdrawing group, it removes electron density. Removes electron density from a pi system, making the system more electrophilic. Making system more electrophilic, which directs the incoming group to the meta position. The COOH group decreases the electron density from ortho and para position, not increase the electron density from meta position. Not increase the density, electron density from the meta position. So you have the assertion to be right and the reason to be false. Hope you got that. Next is question number 9. EDTA is a hexadentate ligand. The reason says EDTA has 2 nitrogen and 4 oxygen donor atoms. Both are correct. Assertion is right. Reason is true. And they are the correct explanation. EDTA has 2 nitrogen and 4 oxygen donor atoms. So it is a hexadentate ligand. Both are right. First option stands to be the right answer. So hope you're clear with this. Next is the question number 10. You have to write the equations for the following. Oxidation of chloroform by air and light. Chloroform is slowly oxidized by the air in the presence of light to an extremely poisonous gas, carbonyl chloride, which is also known as phosgene. CHCl3, it reacts with the half the molecule of this oxygen in the presence of sunlight to give you phosgene, which is COCl2. And HCl. This is carbonyl chloride, also known as. Second part, reaction of chlorobenzene with CH3Cl in the presence of anhydrous aluminum chloride. This is AlCl3. This was your A part, and this is your B part. Reaction of chlorobenzene with CHCl3 in the presence of aluminum chloride. It gives you this compound in minor ortho chlorotoluene and right over here you have parachlorotoluene. This is major. So reaction of chlorobenzene with CH3Cl in the presence of anhydrous aluminum chloride gives ortho and parachlorotoluene as the product, and this is known as Friedel Crafts reaction. Hope you are clear with this. Let's move to the next question. Next is question number 11, section C. On the basis of the crystal field theory, write the electronic configuration for D5 ion with a weak ligand for which the delta. Okay, this is an incomplete question. Let's complete it. The given question is for which the delta naught is less than P. Okay, now I'll talk about the B part later. First of all, A part. It is a magnitude difference in energy between. It is a magnitude difference in energy between the two sets of d orbital. Two sets of d orbital, that is T2g and EG, electronic configuration of D5. Now, if delta naught is less than P, then T2g 3 and EG2, because It follows weak field ligand phenomena when weak field ligands are present in the structure of pairing of electrons does not take place. Let's see it over here. So here you have the degenerate orbitals as like this. 1, 2, 3, 4, 5. Degenerate orbitals. 1, 1, 1, 1, and 1. So here you have, this is EG, this is D2G, this is 3, and this is 2. So here will be 2. Sorry. 1 and 2. Here will be 1, 2, and 3. So 1 electron in each. All right. So now the second part of the question. Explain FeCN6 minus 3 is an inner orbital complex, whereas this is an outer orbital complex. You are given the iron is having atomic number as 26. Okay. First of all, you have FeCN6 3 minus. Cn is a strong field ligand. It is a strong field ligand. So Fe is, we are given that this is equal to 26. So Fe is electronic configuration. This will be given by argon 18, followed by 3d6, 4s2. And if I'm talking about Fe3 plus, because here the valency oxidation number of iron seems to be, from here the oxidation number of iron is plus 3. So this is equal to argon 3d5. This will be 1, 2, 3, 4, 5. So here will be 1 each. And here is 4s and 4p. This is 3d. And now this electrons will be shifted like this. And this. So this, these two will complete. Single, no, no. And nothing. And nothing over here. Like this. So here the hybridization is hybridization D2 sp3. This is inner D complex. Now, if strong field ligand is present, strong field ligand is available, then delta naught is greater than P. So you will have T2G5EG. In Fe, F6, 3 minus. Fe is having AR 3D6 4s2. Fe3 plus will be having AR 3D5. So now the hybridization will be 1, 2, 3, this and this. And to cross. Here the hybridization is sp3d2. This is outer D complex. Now with a weak field ligand, delta naught is less than P. So there is no pairing of electrons in the 3D orbitals. Hope you are clear with this. So now let's move to the next question, number 12. It says a transition element X has the electronic configuration given by this. Predict it. It's a likely oxidation states. First of all, let's start with the first question. So you have to predict the likely oxidation states for this. Okay. 11. On the basis of the crystal field theory, write the electronic configuration of D5 ion for with a weak ligand for which the this is delta is less than P. For a weak ligand for which, let's start with the solution for A. For a weak ligand, delta not is less than P, that is pairing will not occur for D5 ion. That is pairing will not occur for D5 ion. This is something like this. Single. Now this will have a like this is your basic line. Here will be two single electrons, and this is your P single. So this is having plus 0.6 delta naught, and for this is minus 0.4 delta naught. So hope you're clear with this. Now the second part of the question. Explain FeCN6 3 minus is an inner orbital complex, whereas this is an outer orbital complex. Let's write it down. You have FeCN6 3 minus. Here the oxidation number of Fe is 3 plus 3. Oxidation state is plus 3. So electronic configuration of iron, this is having the atomic number as 26. This is given by argon 18 and 3D8. So if you are having Fe3 plus, this will be argon 3D5. Right. Cn, it's a strong field ligand. That is delta naught is greater than P. Pairing, now pairing will take place. So the electronic configuration for Fe3 plus, this will be given by, see over here, for iron, it was single, 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 and 2, 3, 4, and 5, and 4 as 2. All right, okay. This is 1, 2, 3, 4, and it will be complete. This is your 3D8. Okay, now for iron, it will be a ferric iron. This will be like pairing will take place. First of all, this will be like single. This is 3D5. After pairing, now after pairing, this will go over here and like this. So you will have, this is after pairing. And a single over here like this. And these orbitals, this will be empty. Okay, this is D2, D2, S, this is 3D, this is 4S, this is 4P. D2, S, P3, inner orbital complex. Okay, now it's clear, right? I'm writing it again, D2, sp3, inner orbital complex. And for the Fe, F6, 3 minus, again, the oxidation state of iron is plus 3. Fe, F negative, this is weak field ligand. In that case, delta naught will be less than P. Now the pairing will not take place. Will not take place. So it will remain as such. Or this will be something like this. Single. And this will wait. Okay. So now this is 1, 2, and the T also 1, 2, 3, 4, 5. This is SP3, D2, sorry. This is sp3 d2 hybridization. sp3 d2 hybridization. This is outer orbital complex. Hope you're clear with this. Next is question number 12. A transition element X has the electronic configuration given by this. You have to predict its likely oxidation states. So you are having the configuration of X as argon 4s2 3d3. Atomic number of argon is 18. Now you have to predict its likely oxidation states. Okay, so what will be the atomic number of this? This will be 18 plus 2 plus 3, that is 23. So this given element X is vanadium, a transition element. You have to talk about the oxidation state. It will exhibit variable oxidation states of variable oxidation states plus 2 plus 3 plus 4 and plus 5. Now, the second part of the question, complete the reaction mentioning all the products forms two potassium permanganate, two molecules of potassium permanganate. When heated, they will give you K2MnO4 plus MnO2 plus oxygen. This is the complete reaction. Now, the C part, account for the following. In the third transition series, zinc has the lowest enthalpy of atomization. The enthalpy of atomization depends on the extensive metallic bonding. Depends on extensive metallic bonding, which in turn depends on the number of unpaired electron, which in turn depends upon the number of unpaired electrons. The the valence shell electronic configuration for zinc. C part, first question. The valence shell configuration for zinc is given by, I'm just talking about the valence shell, 3d10 4s2. Due to the absence of the unpaired electrons in Ns and N-1d shells, the interatomic bonding is weakest in zinc, and consequently, the zinc has the lowest enthalpy of atomization in 3D series of transition element. Hope you are clear with this. Now, the second part of the question. Cu plus ion is unstable in the aqueous solution. Cu ion is unstable in the aqueous solution because energy is required to remove one electron from Cu plus to make it Cu2 plus. If you have to convert, this is the second question, Cu plus to Cu plus 2, you have to remove one electron from it and energy is required for it, for the same. Hydration energy of Cu2 plus, like okay, wait, see, I'm repeating this whole thing again. Copper ion, if I have to change it into Cu2 plus, energy is required to remove one electron from it. High hydration energy of Cu plus 2 will compensate for the same. Therefore, Cu plus ion is unstable in the aqueous solution and undergoes disproportionation to give you Cu2 plus and Cu. Once again, I'm explaining the second part. Question number 12, a transition element X has the electronic configuration given by this. You have to predict the likely oxidation states for it. So X has the configuration of argon, which is having atomic number 18, 4s2, 3d3. That means it is having 18 plus 2 plus 3, which is 23 electrons. That means it is nothing but vanadium. The given element X is vanadium. Now, if this vanadium is a transition element, it will show the following variable oxidation states like plus 2, 3, plus 4, and plus 5. These are the various oxidation states for the vanadium. Now let's move to the second part of the question. KMnO4, two molecules of potassium permanganate. You have to complete the reaction mentioning the product's form. So when this two molecules of potassium permanganate are heated, you get K2MnO4 plus MnO2 plus oxygen. Hope you're clear with this. Now the third question. Account for the following. The third transition series, zinc has the lowest enthalpy of atomization. See, the enthalpy of atomization depends on extensive metallic bonding, which in turn depends on number of unpaired electrons. Unpaired electrons. The valence shell electronic configuration of zinc, I'm talking about the second part of zinc, is given by the valence shell electronic configuration 3d10 4s2. Now, due to the absence of unpaired electrons of in the ns and n minus 1d shells, the interatomic bonding is weakest in zinc. Consequently, zinc has the lowest enthalpy of atomization in 3D series of transition elements. Hope you are clear with this. Now, the second part, Cu plus ion is unstable in the aqueous solution. See, this is unstable because when you have to convert Cu plus to Cu2 plus, energy is required to remove one electron from it. Energy is required to remove one electron from Cu plus to make it Cu2 plus. High hydration energy of Cu2 plus, high hydration energy of Cu2 plus compensates for it. Therefore, Cu plus ion is unstable in aqueous solution and undergoes disproportion to give you Cu2 plus and copper. Hope you're clear with this. Now let's move to the last part of the question. Actinoids show more number of oxidation states than lanthanoids. Actinoids have a greater range of oxidation number. Actinoids have greater range of oxidation states because of very small energy gap between F1, let's write it, because of small energy gap between 5F 67S subshells. Thus, the outermost electrons get easily excited. Electrons gets easily excited to higher levels, giving variable oxidation states. Hope you're clear with this one also. So this completes your question number 12. Hope you're clear. So with students, with that, we have completed all the 12 questions of this particular set of Delhi paper. Hope you're clear with this. And don't forget to visit our website, www.examsnet.com. Here you will find all the entrance exam question papers along with the detailed PDF solutions. For a better preparation of your exams, do download our app. The link is available in the description box. So students, a very best of luck. Keep shining, keep rising. Hi, bye. Hey, chums of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. Here you will find so many entrance exam question papers along with the detailed PDF solutions. For a better preparation, you must download our app. The link is available in the description box. So students, today we'll be solving CBSE Class 12 Chemistry 2023 Set 3 paper for Delhi. In this particular video, I'll be solving the chemistry questions only. So set 1 and set 2 have already been done and uploaded. Do watch those videos as well, because this set 3 is in continuation with those papers only. Now, in this particular video, let's start with the question number 1. A very best of luck. Here we go. Consider the following standard electron potential values. So these are the two electrode potential values given to you. And this reaction takes place at the cathode and this at anode. Now you have to tell the cell reaction and the potential for the spontaneous reaction that occurs. See, the cell potential is given by potential at cathode minus potential at the anode. And this is equal to 0.07 positive minus of 0.14, which gives you positive of 0.91 volt. This is your potential. And for the cell reaction, it is given by the ferric ion. This will react with tin in the solid form. This is aqueous. This will give you 2 ferrous plus tin will be 2 electrons will be removed from here as well. Okay, this is aqueous and this is aqueous. And let's check with the options now. You have option B as the right answer. Here should be 1. Option B stands to be the right answer to the question. Hope you got that. Next is question number 2. The unit of molar conductivity is. The molar conductivity unit out of these options is option B. It is given by S meter square per mole. Option B is the right answer. Next is question number 3. Out of the following 1M aqueous solutions, which one will show largest freezing point depression? Okay. See, freezing point depression is given by a formula. This is delta TF is given by I into KB into M. Here, this is your freezing point depression. Freezing point depression. I is ionization or vent-off factor. Or vent-off factor. And here you have, this is your cryoscopic constant. This is in, and your M is molality. Moles per kg. Now, let's check with all the options one by one. Okay. Question number 3, out of the following 1M aqueous solutions, which one will show the largest freezing point depression? This depression is given by a formula which is delta TF is equal to I into KB into M. This is your freezing point depression. Freezing point depression. TF is freezing point of the solution in degrees Celsius. I is the number of ions or ionization, or it is also Van Hoff's factor. Your this is your cryoscopic constant degrees Celsius per M, and this is molality, moles per kg. Now let's check each of the options one by one. For the NaCl aqueous, you will have it as Na positive, Cl negative. So your I will be equal to 1 plus 1, that is equal to 2 in this case. The second one, Na2SO4. This will give you 2Na plus SO4 2 minus, so 2 plus 1, here I is equal to 3. And for the third one, this is what was it? Glucose C6H12O6, and the last one is Al2S, aluminium sulfate. So this will give me this glucose. See, glucose is a non-electrolyte. It doesn't dissociate into ions. It's a non-electrolyte. So no dissociation. That means ions is equal to 0. For the aluminium sulfate, you have 2Al3 plus 3SO4 minus. So you have I is equal to 5 in this case. Hence, aluminium sulfate will exhibit largest freezing point depression due to the highest value of I. This makes option D to be the right answer to the question. Hope you got that. Next is question number 4. In the reaction, this gives you A plus 3B plus 3C. You have to find out what is A. So let's complete the reaction. According to the reaction, you have C6H5NH2CHCl3, 3KOH. Alcoholic solution. This gives me C6H5NC plus 3KCl3H2O. This is Hoffman's scopolamine test or isocyanide test. It is not given by secondary and tertiary amines. It is given by aliphatic, aromatic primary amines. This product is foul smelling isocyanide. So that makes first option to be the right answer. Hope you got that. Next is question number 5. Beta pleated sheet structure in proteins refers to which of the following: primary structure, secondary, tertiary, or quaternary structure? See, beta pleated sheet are the secondary structure in proteins where two or more segments of polypeptide chain line up next to each other, forming a sheet-like structure held together by the hydrogen bond. So B is the right answer. Secondary structure. Hope you got that. Next is question number 6, assertion and reason question. It says the backbone of DNA and RNA molecule in a chain consisting of heterocyclic base, pentose, sugar, and phosphate group. Reason says nucleotides and nucleosides mainly differ from each other in the presence of phosphate group. See, the backbone of the DNA and RNA molecules is a chain consisting of heterocyclic base, pentose, sugar, and phosphate group. Let's write it down. Heterocyclic base, pentose, sugar, and phosphate group. This is right. Question number 6, assertion. The backbone of DNA and RNA molecule is a chain consisting of heterocyclic base, pentose, sugar, and the phosphate group. The reason says nucleotides and nucleosides mainly differ from each other in the presence of the phosphate group. See, this assertion is wrong. The DNA consists of two strands that wind around each other like a twisted ladder. Each strand has a backbone made up of alternating sugar, that is deoxyribose, and phosphate group. So that makes the assertion to be wrong, but the reason to be true. And you have the option as the right answer. Hope you understood that. Next is question number 7. Assertion: order of reaction is applicable to the elementary as well as complex reactions. Reason says for a complex reaction, molecularity has no meaning. See here, reason is correct, and the reason and the assertion both are correct, but this is not the reason is not the correct explanation for this assertion. Order of reaction is applicable to the elementary as well as complex reactions. This is right. A complex reaction proceeds to several elementary reactions. Number of molecules involved in each elementary reaction may be different. That is, molecularity at every step may be different. Therefore, The discussion of molecularity of overall complex reaction over here is meaningless. That makes option B to be the right answer, because assertion and reason are true, but reason is not the correct explanation of the assertion. Hope you understood that. Next is question number 8. The final product in aldol condensation is alpha beta unsaturated carbonyl compound. And the reason is alpha beta unsaturated carbonyl compounds are stabilized due to conjugation. Assertion is true, but the reason is false over here. And aldol condensation is a condensation reaction which always gives alpha beta unsaturated carbonyl compound, because these compounds are stabilized due to conjunction. So you have the assertion as true, but the reason is wrong. That makes C option to be the right answer. Hope you got that. Let's move to the next question then. Question number 8. Assertion says the final product in the aldol condensation is always alpha beta unsaturated carbonyl compound, and the reason is alpha beta unsaturated carbonyl compounds are stabilized due to conjunction. See, if I look at the assertion, the reaction typically in aldol condensation, the reaction typically starts with the condensation of two carbonyl compounds. Two carbonyl compounds, often as an aldehyde and ketone, leading to the formation of beta hydroxycarbonyl compound. This compound can undergo dehydration, resulting in the elimination of water, to form beta unsaturated carbonyl compound. All right, and now let's look at the reason. It says alpha beta unsaturated carbon compounds are stabilized due to conjunction. See, beta unsaturated carbonyl compounds have a conjugated beta unsaturated carbonyl compounds have conjugated double bond system, which imparts additional stability to the molecule. Conjugation allows for the delocalization of pi electrons, reducing the overall energy of the molecule, making it more stable. Therefore, both assertion and reason are accurate, they are right, and the reason is the correct explanation also. That makes first option to be the right answer, option A. Hope you got that. Next is question number 9. Assertion says this complex molecule gives a white precipitate with the silver nitrate solution. The reason is the complex dissociate to give chloride and sulfate ions. See, the assertion is true, the reason is also true, but they are not the correct, the reason is not the correct explanation for the assertion. If I look at this complex, the given complex in H35SO4 Cl. This is a coordination compound with the chloride ion in its structure. When a silver nitrate solution is added to it, when a silver nitrate is added to it, you get the white, silver nitrate, not the silver chloride. Silver nitrate solution is added to it, you get the white precipitates of silver chloride due to the reaction of silver with the chloride ion. This, the reason given over here, the complex dissociates to give Cl and SO4 2 negative. This is incorrect. The reason is incorrect because the complex dissociates to give Cl and SO4 2 negative ions when it is dissolved in water and not in the silver nitrate. This will give these two when it is dissolved in water. So this assertion is correct, reason is correct, but this is not the right explanation for the reason. That makes the B option to be the correct answer. Hope you understood that. So next is question number 10. It says why Haloarenes are not reactive towards nucleophilic substitution reaction. You have to give two reasons for this. See, haloarenes are less reactive towards a bond between CX, that is carbon and halogen, because the carbon halogen bond is shorter. Number 10, why haloarenes are not reactive towards nucleophilic substitution reaction? You have to give two reasons for the same. Haloarenes are less reactive towards a bond between CX, that is carbon halide, because carbon halogens, because benzene is sp2 hybridized, having double bond between two carbon atoms. Having double bond between two carbon atoms. Also, halogenes, this was the first one. Also, halogenes showing resonating structure in which the lone pair present on the halogen rotates. Halogen lone pair present on the halogen rotates around the benzene ring, and charges are delocalized, which make it stable structure and do not easily substitute the halogen group. So these are the two reasons why halogenes are not reactive towards a nucleophilic substitution reaction. Hope you understood this. Also, you can say that there's a difference in hybridization of the carbon atom and instability of phenyl cation. So let's move to the next question, number 11. It says, give the reaction of heating glucose with hydroxamine. Give the reaction of heating glucose with hydroxylamine, presence of which group is confirmed by this reaction. Let's write down the reaction over here. Let's make the glucose. Open formula. This is CHO. Here will be CHOH. Then C. Here will be OH. OH. C. C. CH2OH. This is D-glucose. It's completed. This is OH. Here is OH. 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 Sorry, not OH. Here is O only. Actually. I'll make the structure again. This is CHO. Question number 11, give the reaction of heating glucose with hydroxylamine, presence of which group is confirmed by this reaction. Let's make the glucose over here. Here you have CHO, C, 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 and C. Here is CH2OH. Here is OH, 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 H, OH, H, this. So this is your D-glucose. Now it's a reaction with hydroxylamine gives you, this is hydroxylamine heated. This gives you the compound CHO, COH. Here is H. Here is here will be CHNOH, COH, C, H, OH, H, H, and here is CH2OH, OH, OH, and H. This is glucoxide. So an oxime hydroxyl group is present, which is attached to the nitrogen of the imine group over here. Hope you're clear with this question. Next is question number 12. A solution of NiH2O62 plus is green, but a solution of NiCO4 is colorless. Why is that? You have to give the explanation for that. See, if I consider this iron, the atomic number of nickel is equal to 28. If I look at this iron, water is weak ligand, weak field ligand. Therefore, there are unpaired electrons in nickel 2 plus. In this particular complex, d electrons from the lower energy level, lower energy level can be excited to the higher energy level. That is a possibility of DD transition is present. Hence, this is green in color because of the presence of the unpaired electrons. While if I talk about nickel tetra cobalt, this is having no unpaired electrons. This is having no unpaired electrons, and cobalt, this is CO. This is a strong field ligand and causes pairing of the electrons. Therefore, it is colorless. Hope you are clear with this. Next is question number 13. Write the atomic number of the unpaired electrons in chromium 3 plus. Chromium 3 plus. Chromium is having the valency of 24. No, sorry, not the valency. It's having the atomic number as 24. So if I write in the electronic configuration, argon is having 18. Then with 3d5, 4s1. Chromium 3 plus, it's deficient of 3 electrons. This will be given by argon 3d. 1 will be removed from here, 2 will be removed from here. So it will be 3d3. Hence, there are 3 unpaired electrons in chromium 3 plus. Second one, complete the reaction mentioning all the products formed over here. Okay. So let's complete the reaction. This is Cr2O7 plus 3H2S plus 8 hydrogen ions. This gives you 2 Cr3 plus 7 water molecules plus 3S. In the acidic medium, dichromate oxidizes hydrogen sulfide to sulfur. Acidic medium. Dichromate oxidizes sulfide to sulfur. Hope you're clear. Now the C part of the question. Account for the following. The first one, manganese 2 plus is more stable than iron 2 plus towards oxidation to 3 plus state. See the manganese, this is C part. Manganese 2 plus, this is having the configuration as argon 3d5. So it has half filled d orbital and Fe plus 2. This is argon 3d6 plus. Manganese 2 plus compounds are more stable due to half-filled d orbital. Fe2 plus compounds are comparatively less stable as they have 6 electrons in their d orbital. So they tend to lose one electron and get to the stable 3d5 state. So manganese is more stable. Manganese 2 plus is more stable because it has complete, not the complete, actually it has a half-filled d orbital, which makes it more stable than one extra electron which is present in Fe2 plus, which is having the last orbital as 3d6, like this. This is having 1, 1, 1, 1 and 1. And this one is having this. So this extra 1 electron is present over here, which is in the pair, and the rest 4 are unpaired. Now the second part of the C question, C part. Copper has exceptionally positive M2 plus upon M value. Copper has a very high atomization energy and the low hydration energy, due to which E naught is positive. Third part, EU2 plus with electronic configuration given by this is a strong reducing agent. EU plus 2, this is a strong reducing agent because it is more stable than EU. Electronic configuration 4F76X2 after the removal of 2 electrons. This. After the removal of 2 electrons it achieves the half-filled F orbital. Electronic configuration acting as a strong reducing agent. So this completes your Question number 13. This is the last question of your CBSE Set 3 chemistry paper, Delhi. Hope you're clear with this, and don't forget to visit our website www.examsnet.com. Here you will find all the entrance exam question papers along with the detailed PDF solutions. Students, you must download our app. The link is available in the description box. So keep shining, keep rising high. That's all for this paper. A very best of luck for your exams. Bye.